Hello. Hello. Good morning, everyone. Myself, Priyanka Tupad, Assistant Professor, Department of Computer Science and Engineering. It's my immense pleasure to welcome you all for the webinar on Introduction to Kubernetes, organized by Department of Computer Science and Engineering, BGMIT Mudol. First and foremost, I would like to welcome our today's speaker, Shri Ijajahmed Momin, Professional System Admin, DXC Technology Bengaluru. Welcome you, sir.
Thank you. Thanks for this opportunity. I'm really honored to speak in front of all your enthusiastic students.
Welcome, sir. And also, I would like to welcome management, our beloved principal, Dr. S.P. Kerur, Professor B.G. Kumbar, HOD, Department of Computer Science and Engineering, Mr. Sandeep Koppa, Event Coordinator, heads of all the departments, coordinators, teaching, non-teaching staffs, students, and all participants. Welcome you all. Now, let me introduce Speaker of the Day, Shri Ijajahmed Momin. Sir has completed Bachelor of Engineering in Electronics and Communication from BMS College of Engineering, Bangalore in the year 2008. Sir has got 12 years of experience. He spent 6 years in USA working for a telecom giant in AT&T. He worked as a module lead in Tech Mahindra Limited from 2008 to 2018. Since thereafter, he is working as professional admin in DXC Technology Bengaluru till date. It's our great pleasure to have you with us, sir. I now request our today's speaker, Shri Ijajahmed Momin, to please start the session. Please, sir.
Okay, thanks for the introduction, and once again, it's my pleasure. I couldn't be so grateful when Sandeep, he's my school friend. We studied together. He was my classmate. So he came up with this thought, and it's a brilliant thought, I would say, and it's an you all the students of this college should be proud of that, because having arranging these sessions are very difficult, and that too in such a difficult time of this year, and so all the faculties and all the uh, the college members, they have come up with this thought, and having these webinars, and introducing students with this outside world. It's really a great thing. So you guys should be very happy to basically happy to be part of this college. And let me start. Let's forget about this Kubernetes stuff right now. Let me start with uh, yeah, we just completed Engineers Day, right? I mean, you guys all know about it, and I'm pretty sure that you guys have greeted each other, right? So so I mean, we actually engineers are making the world right now, right? I mean, we are the one who is shaping this world to the future. And as you can see around you, there are so many things which are uh, technologically ahead of our time. And some of them are like we're still using the old technologies as well, but we as an engineers, we are always thriving, or thirsty for the new technologies. So similarly, it wasn't the same thing when we passed out, right? I mean, like uh, so at that time, I mean, we didn't have all this latest tech stuff. I mean, currently, I mean, as you can see, you might be going through all this the articles and technological pages or everything, whatever it is. But you should be seeing so many new things coming up. We back in the day, we didn't have all this, so we had the same old technologies, but we still we were able to learn them, and then we cope up with them, and then uh, Currently, like last 5 to 6 years, we have been developing our skills. But it's a great opportunity for the newcomers who are, really fresh with their mind. And as soon as you go out of your college, you will definitely have a very big world in front of you, where you can, simply go in and, when you learn a cutting edge technology or a latest technology or trending, whatever trending in the market, so you will be the first one to choose, you will be the first one chosen for the job, right? So uh, that's the story of an engineer. I mean, like, you come out of the college, and then you basically learn some new things, and adapt to the corporate culture. So yeah, and then obviously start developing your skills, and then you become a lead, you become a manager and all that. So you keep climbing. Okay. uh, I mean, currently it's very important for us to keep up with these technologies. I mean, for me, I have been always looking something new every time. The reason is, so one thing is, I mean, you will have to keep up with the technologies to compete with the world. And second thing is, and obviously you'll have to take care of yourself, right? So you need all these things to basically live. uh, as an engineer, I mean, let it be a software engineer or mechanical or chemical, whoever he is, so he has to be keeping up with all these the latest techs which are in the market. So so be proud of an engineer, right? I mean, you guys should be very proud of that. And uh, I'm after this session, I mean, I would like to see at least, I mean, all of you, not at least all of you, uh, should be aware of what's in the market and what I should be going for in the future, right? So uh, I mean, I agree it's not a lengthy session. I mean, I'd like to keep it short, and I'd like to impart all the important stuff to you guys, not just not to bore you guys, obviously, right? So let's start. I see we have 20 participants already on the call. That's pretty good number. So I hope you guys don't have any problem listening to me. I mean, I hope my mic is clear, and I hope my presentation is also visible. You guys always, have an option to chat. There's a chat section, so you guys always, can just click on that, and then if you have anything in the anything, any a doubt or any queries, or if you guys have any problem hearing me, or watching my screen, everything, you just keep posting in that chat window. I mean, I am watching it continuously, uh, and I mean, you guys feel free to just put whatever are you use. Okay. So let's start with the session for today. So as you guys already know, I mean, the session is on Kubernetes. Uh, it's called as KATS as well. So let's move on with the session. Okay. So today's agenda is, I have collected some of the very important topics. These are important in the sense where these will tell you what is Kubernetes, and there are different technologies available which are in competition with Kubernetes, and then containers, uh, and the containers of the current world, and the virtual machines of the I wouldn't say previous world, because we're still using them. So I would say, like, uh, you know um, uh, basically we'll learn about the differences between both of them, and then we'll learn about the Kubernetes architecture, And we'll learn one very important part of the Kubernetes, that is kubectl, kube control. We're going to learn that as well. And then I have a few of links which I'm going to share with you guys, so that you guys can continue after, when you guys leave the session. You just have to go through those links, and then basically uh, learn about the Kubernetes, because you'll have to basically, if you just break the chain, obviously you will just forget everything. So I don't want you to break the chain and then keep learning this stuff. Okay. And then I have a session Q&A. I mean, obviously, if you have any questions at that time, you can definitely put it in the chat. uh, if possible, you guys, while we are doing the session, let's put everything in the chat window, so that I can collect your questions, and then basically answer them at the end of the session. Okay. So excuse me, let's move on to the next slide. So I collected couple of sorry, I collected couple of statements, what exactly is Kubernetes for. I mean, even though I wanted to put just one, because I like both of these, so I wanted to just show you guys what exactly is Kubernetes in a single slide. So uh, so what is Kubernetes? I mean, I hope you guys have heard about it. You may have read it. You may have read an article or something, or you may have you know worked on, or you may have already practiced all this stuff, um, right? So so it's an orchestration platform of the containers, where obviously you can set up multiple nodes, where your containers are running. And these nodes can be anywhere in the world. Okay. And they have a very good high availability feature, or you would say like failover, right? So that's one part of the Kubernetes. Okay. And the next part is, obviously, Kubernetes is very portable, and it is extensible. You can scale it. uh, Another important thing is it's an open source platform, and it was actually brought in by Google at the beginning in 2014. um, so as I told, I mean, we manage the containers, um, let it be a workload or the service or anything. um, and another important part of it is like, uh, it's actually it's rapidly growing. I mean, everyone is looking for Kubernetes right now because of its feature. I mean, at the end of the session, I mean, you would definitely come to know why. I mean, why do we need this, right? uh, yeah, we'll get to that definitely, but for now, you just fix this in your mind, that okay, what is Kubernetes? Okay, it is an orchestration platform for the containers. Okay. So you just remember this, and then just build your knowledge based on this line of Kubernetes, right? So you just keep building it, right? So obviously, it provides services, and there are many tools, and you can do a lot of automation, and so many things you can do. It's very difficult to cover all this in a single session. I mean, you would need like 10-15 sessions of it, uh, but as of now, just remember this point of the Kubernetes, where Kubernetes is an orchestration platform, and then you can set up multiple nodes, and uh, which are geographically dispersed. Okay, that's all you should remember for now, right? So let's move on to the next slide. So there are like different technologies available, which are competing with Kubernetes, but Kubernetes is one of the top one right now. So most of the tech giants are using it. and it's very it's very easy to basically deploy your application. So in a way, in a single way, it's easy to manage. I have worked on it for 3 to 4 years. I mean, I've been working on it since ever since I've joined DXC, and before that as well. So before that, I used to practice it, and then when I joined DXC, I used to basically manage this application of AT&T, where you know uh, we do a lot of Kubernetes stuff. So I don't want to shift the gears right now, but it's very important to learn what is a container. Okay, I mean, you can imagine container as a small package, right? So uh, many of you already know this. Uh, when you write a code, when you build an application, so what you do, I mean, you basically host it in a server. That's the basic, right? Everyone does that because you want that application to be available for all the users, isn't it? That's the whole purpose of it. So what happens when when you host a application on your server, and it depends on like where you're hosting. Like in my experience, I have hosted an application, or I have maintained an application on Linux or Unix, I mean, or you can do it on Windows as well. So, but Linux and Unix are more. I mean, like I have worked on those, and they're more secure. Um, so, in olden days, I mean, many of the company they still use the physical servers, but in past, I mean, like many of the companies they have given up all that, and nowadays they have come up with all this cloud stuff. So what we I mean when I started to work in a company, we used to have like all these physical servers. um, so we used to host one application, or in a single Linux or Unix server. So it used to have like maybe like uh, you know uh, 2 TB or 5 TB of physical memory, maybe 8 core CPUs, or 16 core CPUs. So it used to be a single server, right? So you guys know of this stuff. I mean, it's just like your laptop. You have a certain memory and then CPU and all that stuff. So you you run one application on that server. So you host your application on that server. So that used to happen in the past. So now what happens is you can basically create a package of your application where it has your code, it has all the library files, and it has all the tools or settings, everything, right? So you have all that stuff packaged up, and then you just put it in a Docker container. Okay, so and then you create an image of that. So the image will be created when you have certain commands to do that. You basically run those commands in a Docker terminal, and then you have your image created, and then you can use that image later on. Like, okay, I'll tell you how to do that. But yeah, for now, just remember, you just packaged all your code, and then all your library file dependencies, everything, and then you just put it, in a Docker container, and you created an image, right? So, uh, as I told you, uh, we didn't use this technology in the past, right? I mean, you just hosted one application on the server. You just dumped your application on that server. So that server, let it be a big server or a small server, whatever it is. I mean, you have your application running there, right? So now, I mean, you have a Docker container. Okay, it's everything but your OS. Okay, because your OS will be on the VM or wherever it is. So your OS will be maintained by that server, but your container is just your application core and then its dependencies. Okay, so what happens like when you create an image? So you basically that you can use that image and then put it on a orchestration platform like Kubernetes, so you can just put it there and then run your application. Boom, so you create a deployment and then you basically run your application on the Kubernetes. So what is the use of it, right? So first thing is, the containers are very lightweight. And I mean, they're very lightweight, and they don't have anything. I mean, they basically, as I told you, right, it is just application code and then some of the libraries and then tools, right? So it does not have that OS where you have a in a monolithic world. You have this server, and then you have OS upon, I mean, you have the kernel, and then on that you build your application, right? It's not like that. It's just your application code. It's very lightweight, and it's very secure as well. Okay, and then obviously nowadays everyone is using it, so it's very industry standard. So many of the giants, technology giants, they're using this technology. So sorry. So you basically you can just write your code and then create an image of it and then use that image. Many times you can use that image, because it will be there in your as an image. You can keep it in a like a repositories, like we used to use Maven, so you can keep it there. So you can store these images at one place, and then as you need it, you can just pull it. Okay, so as simple as that. So I hope this is clear. I'm not running too fast. I hope this is clear. You can definitely put it in the chat. I mean, if you have um, any questions or doubts, or if I'm going too fast. Okay. So here is a small picture of what container is. As I told you, obviously there is a physical hardware, or maybe it can be a virtual as well. Nowadays, I mean, we are using VMs. Uh, so you have a physical or virtual machine, and then you have an operating system running on that, and upon that you build your Docker engine. So you have your application, all the process or whatever it is. So you can run multiple applications of it. So this is a very small picture where, I mean, it shows you like what container exactly is. So um, I hope this picture is very clear. I try to make it as simple as that, so that you guys can easily you know uh, understand. By just looking at the picture, you should know, okay, this is the hardware, and then there's an OS running on that, just like your laptop or your PC, right? So you have your um, machine, and then you have your OS installed, whether it be Ubuntu or Windows or anything, or any other Linux flavor. So, and then you have a Docker engine running on that. I have installed Docker in my laptop as well, so you guys can always install it and then play around. Um, I mean, I can definitely show you how to do that. Um, uh, so now that, I mean, we learned what container is. I didn't spend obviously I didn't spend much time, because containers is a very huge topic itself. So I try to put it as short as possible. So now that we learned what a container is, so we'll have to learn like how Kubernetes and containers, how can we basically relate those, right? So uh, in this world, I mean, everything is a container. In a DevOps world, so uh, because of its features, so it's vastly used, and nobody is going for a fully fledged server just to you know host your application, or run your processes, or whatever it is. So they're not going for that anymore. um, so as we learned, like you bundle your application, then what you have to do is, like, let's say you are running an application in a production environment, so you just have to run that application, and then make sure that there is no downtime at all. Like, so for example, take an example of Amazon. So Amazon, it has all of its applications, all of its features as a microservices. Microservices basically, it's a teeny tiny service. Like, in a monolithic world, what we used to do, like, we used to host our application on WebLogic, where we used to have like your whole application tied together. Okay, but in a microservices world, you have your applications broken down into services, teeny tiny services. So those service each of the services do a different functionality. Okay, Amazon is a biggest example. If you go to Amazon.com or .in, so you see all these menu options, or let it be ordering system or billing system. So they're all different microservices. So what I mean, what is the use of it, right? So you may ask me. So let's say you have your application, and then if anything happens to that server where your application is running, right? Or whatever it is, or a data center issue or something, or maybe a physical server issue itself, or your application will not run anymore because your server is gone, right? I mean, it's dead for now. So you need to make sure that your application is running. Then only users will use it, correct? So that is the main intention of it. Like, you need to make sure that your application is available to the user, so that they can use it, and you can get money, or you can make money, or you can uh, you know serve your clients, right? So it has to be available. So excuse me. So for the same thing, microservices, where this whole technology was brought in, where, I mean, you can basically write a chunk of your code, and then uh, you can host your application in a microservices, in a microservices way, I would say. So uh, Amazon, where I mean, they have all these different features of their website or their app written as in different microservices. So they have, I mean, each of the service is running in a different pods. I would say we'll come to that. So it has a multiple instance of it. Like, if one instance goes down, or if one server goes down, so it'll run on a different server. Even they have like geographical dependency, sorry, a failover as well. Like, if one data center goes down at one location, the other data center will be available. So that's why you hardly see Amazon.com or Amazon, or any of the Amazons, they are going down, right? I mean, you hardly see that happens. It never goes down. It is always available to their users, so that they can use it, and then they can purchase the products on them, hosted on the Amazon application, right? So that is the biggest example. I mean, you should know, like, uh, where exactly I'm going, right? So you have to make sure application is hosted on a very good platform, and then you have to they should be easily manageable, and they should be available all the time. I mean, there shouldn't be any downtime. Okay. So what happens is, I mean, if, let's say, for example, you have a container running on one A server, and if A server goes down, or if the container goes down, so B server should start that container automatically, right? So how you do that? I mean, you don't have to sit there manually do it, right? So then Kubernetes comes into picture. Okay. So it constantly monitors all its containers. So uh, if one of the container goes down, so it'll spin up another one. Okay. And it'll make sure that your application never goes down, and it's always up and running. So that's where the Kubernetes comes into picture. Okay. So This is one of the reason why many of the companies are they're going with Kubernetes, uh, where I mean it can be it can come very handy in such cases where you have to keep your application running 24/7, 365, right? And another thing is, let's say for example you have one application and you have like maybe a million of users, right? So and if one application is there and one container is it is running on one container or a one pod, I would say. So obviously you will overload that application. You don't want to have that as well, right? So 1 million users and hitting that one application simultaneously. So you can, in Kubernetes you can scale the application. Like you can have like many number of pods depending upon your size of your physical server, and depending upon your configuration, right? So you can basically have different pods. For example, you can have like 30, 50, or or 10, like depending upon your application usage. So if you have like it's always better to have 10 instead of one, right? So obviously because one application is running, so all the million of users, they'll start hitting it, and your application might crash. So what happens is when you have 10, your all those 10 pods will take transactions, and there's obviously a load balancer in between. So all these pods will take transactions, and then your application is still up even though there are millions of users hitting that application. So these are the many of the these are some of the reasons where I mean Kubernetes comes very handy. Okay, so you can easily manage all your deployments, and then even you can control your deployments, and then you can set up all the failover of your application. So there are so many things you can do. um, I hope the container part is clear. I just fit this in your mind, uh, what container is. You can say you can container is a bundle of your application. So you can just maybe in a generic way you can just remember this way. And then as soon as you go out of the session, you just maybe I'll give you the link so that you can just go there, and then start exploring, like learn more about the Docker and then containers. So you can just Google it around. That is also a good way to learn. Initially I told, right, I mean I wanted to basically touch base with what the virtual machine or the physical machine is, and then what the container is. I did mention about it in my previous slides, but I mean I wanted to put it in a picture where you guys can see the difference between both of these, right? So you have this picture in front of you. There's uh, one section is the virtual machine. uh, I hope you all know what is virtual machine. uh, Basically you can just pin one virtual machine in your laptop as well. You might have already done it in your uh, on your personal PC or the laptop. And the other section is a container. Okay, so you have obviously hardware is same for everything, and then you have the OS. Okay, OS is obviously needed to run any application. And then you for the virtual machine you have something called as hypervisor, where you can basically control all your VMs, and then you can basically scale them whatever way you want to. But in case of a container, a Docker comes into picture. So Docker, where I mean you can upon that you can build your containers. Just see the example here. The application has this virtual machine has application libraries, and many other dependencies, and then OS. That's very important. So a virtual machine needs to have the OS. Okay, but just look at this. There's no OS here. So containers does not need an OS. It uses the host machine's OS. and you don't have to basically couple your OS with the container, right? So this is a very important part here, guys. I mean, you just need to remember this. Container is everything but the OS. I mean, I usually take it that way. So if you see the utilization, so what happens is, in a virtual machine you have like gigs of data, gigs of memory. So the reason is you need OS takes around, every time, I mean, when it runs, it takes around 5-6 GBs or something, depending upon the size of the, depending upon the flavor of the OS you have. So it takes GBs of data. So you don't want to do that, right? So why do you want to waste all your space? On the other side, see, the container takes the, uh, the MB of data. So that's a huge difference here. You can save some space, and then it runs. Obviously, it boots up pretty quick because you don't have the OS. So when you have the OS, it takes, obviously, you may have seen booting your laptop, or booting your Ubuntu machine. It takes some time, right? So but container, no, I mean, it's pretty quick. So it boots up pretty quick, and it doesn't even use a lot of memory. So this is the main difference between the virtual machine and the container. So everyone is, going for this containerized technology. Okay. Because of this reason, and then because of many other reasons which I have already explained, right? So those are the reasons why everyone is, looking for this. So when you guys go out of your college, so obviously you will see all these things practically. I mean, you may practice now, but you will see all these things live. And then uh, you start working for some company, and you see all these, maybe you may see a virtual machine there, or many of you may end up being a system admin, or maybe developers, even whatever your role may be, you will see all these technologies. And depending upon your role, uh, and your interaction to all these things varies. So if you are a developer, basically you you will have to, interact with your you know code, and then you will learn all those stuff, and you will see how to basically get your code to the market, to the testers, and then you have to make sure all that stuff. So you will learn all that stuff. But when you become a system admin, you will have more exposure to all these things, because you will be managing the application, right? So you will be saying the virtual machine, where, I mean, you will be basically logging into that, and then you'll be looking at all this uh, you know processes and everything. I mean, you will, just like looking at your laptop, or your PC, right? So similarly, uh, if you are a tester, you will also come across all these things. So you should remember, all these terminologies, where you can, uh, build your knowledge on, right? I hope I'm very clear with the difference on VM and container. uh, I didn't spend much time on this, because the picture is, it's self-explanatory. Excuse me. um so uh so whatever I told in the previous slide, I just put it in the word. Uh, so I'm not going to spend much time on this, but I'll just, quickly cover this. Um so we learned what the container is, and how useful it is, and why do we think it is very useful, and then how they're coupled with the OS. I mean, you see that there's a Docker engine in between. So there are some of the other benefits where containers are pretty useful. So first thing is, I mean, they're very efficient, right? Because they boot up very fast and they don't use much memory of yours, and then they're in this way they're very efficient. So, and in a world of continuous development, CI/CD, continuous development and continuous integration, you need your application to basically go to the market pretty quick. So you don't want to wait on anything, right? So you want your application to go to let it be test environments where the tester can test it. So you want that to happen very quickly. So you have to get your application right on the platform. Similarly, in the production, so you want your application should not be down for more time, and you should be bringing up in case of a deployment, so where you have to bring your application up very quickly. So in those cases, I mean, uh, containers they come very handy. That's one of the other reason. And so, I obviously I didn't speak much about the DevOps. If I get an opportunity to speak on that, I mean, I can definitely speak on this. But in a DevOps world, these containers are, uh, I would say, like they're. I mean, I wanted to use a good word, but uh, so they're very helpful for the developers and then operations and everyone, right? So you can create your image and then build it and then put into the release. uh, you can do it pretty quickly, where you can basically host these applications uh, by as the picture suggested, right? So you host your application. uh, you know you see this, there is no link. I mean, it doesn't have to know all these things, right? So your application doesn't have to know all this, but in this case your application should be coupled with your infrastructure. But in this case, no, it doesn't have to be. It just knows the Docker, and Docker takes care of all these things. So uh, your your application is decoupled with your infrastructure. That's one of the reason why it is very efficient, right? So that's one reason where, I mean, it comes very handy. And well, coming to the next part of it, I mean, as I've told you about the microservices, right? So microservices, I mean, you can build a microservices of your application instead of creating one big application. um, because if anything happens to your server or something, your whole application is down. So you don't want to have that. You still want to, for example, you're billing, you have a billing, you're ordering and billing system. You don't want everything to go down because users can't order anything and you can't bill. uh, if you have a microservices for ordering and then billing and everything, so you can at least, if your application is up on ordering, and then you can just at least take orders. You can do the billing later. So as many things are there. So you will get to know all these things when you go to the industry, right? So and one of the cool feature of containers is, I mean, your application is same. It's same in all the environments, except some of the configuration changes. It's very consistent. So that's one of, I would say, like one benefit of it. uh, so here, I don't want to spend much time on this slide. The reason is, I mean, I have already explained all these things, uh, how good the container is, right? And we already learned the difference between the VM and um, the container. Okay, so here comes the important topic of this session. Um, so just focus on this slide, guys, and then see what exactly is the Kubernetes. I mean, I try to put a picture which is which should be helpful, so you guys can see uh, how the architecture of Kubernetes looks. So you have a master, right? So obviously it's a master and slave, um, sorry, architecture. And you have in a master you have like there's a scheduling, and there are REST services. Don't worry about those: the scheduler, replication controllers, and etcd. So what happens, as you may remember, I told in my previous slides where I told uh, basically you can orchestrate all your containers. So when I say that, it means if any of your container goes down for a reason, so Kubernetes knows that. I mean, it can quickly, it has all the configurations stored, and in its master. Okay, and then it knows like, okay, whenever container or whenever the pod goes down, it spins up another pod, right? So it automatically creates it, and that pod will be of this, it'll be of the same image where your previous pod was, which went down, right? So it will be the same, and it can do, you know uh, you can specify the limit, like how many pods you want. And obviously, if any of the pod is going down for a reason, let it be a server crash or something, uh, the master knows it, and then it quickly spins up another pod so that your application is should be available to the users. Okay, so this is where all the logic is stored. And this is the slave, where you have your container, and then you have your pod, and then you have the services are like, I mean, where you can expose your uh, excuse me, you where you can expose your application to the outside users, right? So you can basically use a DNS, or you can use an IP address, and then port, and then your application will be hosted on that, and then you can just give that URL to your app users, and then they can access it. So your services will be there, coupled with your application. Mind you, the port of your service will not change until unless remove your service, or you delete it and create it. So it's always same, the port always remains same, so that app users uh, don't have to change the URL every time you deploy your application, right? So you have your pod, you can have a number of pods depending upon the size of your slave, depending upon the resources on that slave node. And then similarly you can have multiple slaves, right? So this is one slave node, you can have like another slave node here, and then you can have another one there. So you can have you know a number of slaves and then a number of pods. So now you understand like uh, how good is Kubernetes in terms of managing the application. So you can host your application on, like, for example, this is slave one. You can do it on slave two, slave three, and then three. All these three can be in different data centers. One can be in Delhi, or one can be in Mumbai, one can be in Chennai. So, and then you can simply host your application. If one of the data center in Chennai goes down, and then your Delhi and then Mumbai is always running, right? So that your users can still access your application. So kube proxy is the one which is in between it. It manages all your connections from the user to your application. So this I mean, I hope, I mean, this is clear to you guys. I try to make it simple, uh, and I'm not using much technical stuffs here, technical keywords here, but I'm just trying to put in a generic way. So that's what a Kubernetes does. I mean, it makes sure your application is available, and then you can scale your application based on the volume you get, and you can easily manage your Kubernetes cluster using kubectl. Sorry, uh, you know. I'll go to that. Using you can manage using the REST services, or you can manage with kubectl, so you can manage your Kubernetes cluster. Okay. So this whole thing is a cluster. You can have multiple masters, you can have multiple slaves. Like when I worked, I have like I had like 3 masters, and then 50 to 60 slave nodes. It just depends on your application, how big it is, and how much uh, like uh, how much volume it gets, how many users are there, and all that stuff, right? So, yeah, it's just a continued part of it. It just shows like how they use this, and then they connect to your application. There's a queue proxy in between, and then there's a pod IP address and the port. And similarly, like there are pod 1, pod 2, pod 3, and then you have a web server hosted on your application, on your container, right? So this is you can have many number of these pods. Okay. As I told in my previous slide, where you can manage your Kubernetes cluster with kubectl, right? So kubectl is one of the handy on command line tool. So you can control your cluster. You can view, edit, and you can do all the configuration changes. You can look at the deployments. You can look at the pods, and then you look at the details of the pod, and then you can look at the services. You can look at the details of the services, everything. And so you have something called as YAML. There's a YAML file. It's actually a human readable data serialization file, where you can just uh, have a certain human readable information, where you can it has its own structure. You have all these YAMLs, creators you can use, or you can structure it using the all those tools which are available. uh, so uh, you can use that file, and then you can create your deployments, you can create your service, you can do all that, all the fancy stuff here. So um, you can once you like if you really want to learn this, you would go ahead and then install Kubernetes Docker in your system, and then you can install Kubernetes. Basically you can start with Minikube. You can install it. I'll give you the link where you can learn all these things. And then once you do that, you can run kubectl commands on your laptop. For example, I wanted to really show you how this thing works. So here, if I run kubectl get pods, it shows me the pods, whatever pods which are running on my Minikube. Okay, so I have like in Nginx, this is the server. So I have these pods running. Okay, and let me quickly show you how the Kubernetes class, the dashboard looks like. So this is the Kubernetes dashboard, guys, where you can have your namespaces. Okay, and then you can have your roles. You can assign a person a different role. Okay, and then you have your I don't want to cover all these things because it's going to take a lot of time. And then you have your node. I have my own node, like I have my Minikube running on my laptop. So this is you can see this is the CPU, and then this is the memory, and then this is a limit. So you can specify limit, like you can put like 1 GB, 2 GB, and then you can put the CPU limit also, like 1 2 or number of cores. uh, Sorry. And I was speaking about earlier, I was speaking about the deployment, right? So this is the deployment where you can uh, this is the form of a this a YAML file where there's a deployment. Uh, as you can see here, this is a kind of a deployment. So you can just run this YAML file on your cluster, and then your deployment will be created. And then based on the number of pods you have mentioned on this, or the number of replicas you have mentioned on this, so you will have those number of pods created. So you have this deployment. I mean, let's say for example, you write in a Python application, right? So if you are very interested in Python, you can write an application in Python, and then you can host your Python application on Kubernetes, right? So you can just deploy it, and then you can see here your application, Python application pods will be started, and then you can launch the URL. I'll show you how to do that. And then you can once you launch your URL, you can access your Python application which you have written and then hosted on the Kubernetes, right? So uh, these are the number of pods. As I told, I have two replicas here. So replicas means like just like how many pods you want to have. Like there are two pods, and it shows the pod name, and then namespace. I don't have a namespace. So and then label, and then node where it is running. It can be a physical server, host name as well. It can be a Linux, Windows, anything. And then status, it is running. And let's say for example, so if for some reason if it goes down, like if the status goes down, or if this pod goes down, the Kubernetes will spin up another pod, and then it will make sure that there are two running all the time. And then usage is 0 because nobody is using it. And then how much memory it is taking, it is using like 2.26 MB, and it created an hour ago. And here, I mean, if you click on this, I mean, you can basically edit, and then you can look at the logs. uh, it'll just tell you the logs, where I mean, now I mean, I don't have any logs because I'm not accessing this. So um, yeah, that's pretty much about the pods. I wish I had more time, I can cover all these things, but that's fine. uh, let's go to the, I told you, right, I mean, services. So here, uh, if you click on this, um, so you have your application running on 8443 port, and this is your IP address. So if I launch this and with this port, your application will be available in this host and this IP address. Okay. So that is, and it never changes until you recreate your services. So this is the standard Kubernetes dashboard looks like, where now you learned, right, I mean, how easy it is to manage your application. I mean, like for example, if I want to bounce this particular pod, I can just delete it. So if I delete it, and then what happens is, as you can see, another one is starting. So it started, and this one goes away. So at any point of time, it makes sure that there are two pods running. Okay. And then you see the time on that pod. It shows like 14-15 seconds. So you can have like many number of pods. For example, if I go here, and then if I scale it, if I can scale it to 5 scale, and then I should see 5. 1 2 3 4 5. Now 5 instances of my application is running. How good is that, right? How cool is that? I mean, it's very you can't do this in your in a monolithical world, where you can just you have your one application running there. You have to bring one other server, right? You have a server, you have your application, you have to build one more server, and then you have to connect those servers with a load balancer. But here it's very simple. You can just spin any number of pods you want. These are all your applications, and then they all start taking traffic as soon as users try to use their application. So this is how cool it is. Okay. Let's see if I can cover anything. Config maps, where you have all your config stores. I don't have anything right now. And then secrets, where you can keep all your secrets. You can keep all your certificates or your passwords and everything. You can keep all these things here. You can keep your token. So all these things you can keep here. These will be useful when your application starts, and then when your application is accessed, using your http using a https protocol. You need to have your certificates ready, so that you know uh, your application is secured. Okay. Let's see if I can cover anything. Let's go to the slides. That is kubectl. Okay. uh, Here I have a couple of links. I'll just put it in the chat. You guys can copy it for sure. Let me open this. Okay. Sorry. I have it open anyways. Never mind. I'll just open it here. So this is the Kubernetes page where uh, you can definitely go here to the documentation, and then you can learn all these things. I mean, as I have already explained, it shouldn't be very difficult if you go to all these basics, and then you can basically build your own Kubernetes dashboard. You can on your laptop. So you can there are many examples here. You can they're very self-explanatory, which I could have time, I could have shown you all these things, but these are all self-explanatory. I mean, you can just go in there and then learn. uh, so and then obviously you can set up your cluster, but you don't need to do that now, but you can just uh, try to just go through all these basics, and then just learn the Kubernetes, and then kubectl, as I told, like kubectl command. Okay. So you can see 5 are running there, right? So you can do all cool stuff here in this site. I'll just post this link in the chat. Okay. Oops. I should send it to everyone. Okay. So you all should have it now. You guys can launch it and then learn it. uh, let's see. So any questions or concerns or anything which you don't understand or which you may have any doubt on, I'll take a pause here for a few seconds and then wait for your questions. If you have any questions or something.
Hello, sir.
Hello.
My name is Varun. I'm a faculty working here, sir.
Hi, Varun.
Hello. I have one doubt. Is it having a similar features to that of Anaconda? Because our students use Anaconda for machine learning lab.
No, Anaconda is actually IDE, right? So you can uh, where you have do you use it for like building like in a Python? I'm sorry. I don't know for what you use it.
Yeah, we
But
use it to run our machine learning programs actually,
okay,
which is part of our syllabus.
okay. So here's the thing. I mean, that's totally different, because this is a, a purely orchestration platform.
Okay,
It does not have anything as such, where you can run your programs or something. But it allows you to do that. What you can do is you can write your machine learning code, and
okay,
then you can host that code in Kubernetes platform. So as I shown earlier, like I have a couple of applications here. I have nginx server. So
okay,
similar way, you can write your code, machine learning code, and then you can host that code on this platform, and then you can access that code using the IP and the port, where I
okay,
shown you guys, right? Like where you can look into the services, and then you have your application access through this IP and port. So you can definitely do that, but they're totally different from each other.
okay, okay. Thank you.
Thank you for the questions. Any other questions?
Isaz, hi, Isaz, Sandeep here.
Hi Sandeep.
Isaz, most of our students have a questions regarding the job opportunities for system admin, and they have doubts what kind of responsibilities you will be having, and which all companies offer jobs for freshers, and the salaries regarding to it. Because at
Okay.
their level of knowledge, they have this kind of questions. So, as a
Yeah.
fresher during academics, what all things I need to learn during the academics, whom to contact at the basic level, how I can prepare for such things, those kind of questions. Uh, just to
Okay.
give highlights, important suggestions on that.
Yeah, sure. See, obviously, when you are currently you're in a college, right? So uh, you have to build your basics. I strongly believe that we have to be strong on the basics. So what you can learn in the basics, so you have to learn all the operating systems like Linux or Windows. Okay, Windows you already know, but you have to start learning Linux if you want to do a system admin job. So you have to first know the Linux or Unix, because every each and every company in this world is using Linux, either Linux or Unix. So nowadays, I mean, Linux is Red Hat Linux is very famous. So you should learn Linux, and then you should learn Linux commands. So there are many commands available where you can just on the Google, if you just go to unix.com or anywhere, you can learn all these commands. So you should know all these things. That's the first step of yours. uh, like simply copying the file or moving the file and creating a file, and then there are some of the complex regular expression commands like awk, grep, and all that stuff. So you should know all these commands. That's your second step. And the next step would be like how basically how your application is hosted on on a server. So you should know that as well, because ultimately, wherever you're going to work, your company has an application. For me, like the client whom I used to work for, they had like very big billing and ordering applications. They were they're all running on a Linux server. So you should have knowledge about those, because you will be managing those applications as well. If you're working as a core system admin where you are just managing the OS and the Linux part, you should definitely know OS, and then you should know networking part of it, and then you should know all the commands. Start from the basics, and then you should know all the complex commands. Okay, that's your first step as a system admin. And for my job, I used to work as a DevOps engineer. So I didn't have to learn the OS and all these things, but I did learn all the commands. And then I did learn the shell scripting. Shell scripting is obviously you may be writing Python scripting, right? So similarly, you have shell scripting. Obviously, it is not advanced as a Python, but you should know shell scripting because you'll be doing a lot of automations, or you'll be working on the complex tasks where you will have to write a shell script and then reduce your work, and then a lot of uh, management of your application or your servers that happens through shell scripting. So that's the third step of yours. Okay, you should know shell scripting. And coming to the questions where excuse me, so which are all companies. So nowadays everyone looks for system admins. For example, you know um, let it be DXC, Tech Mahindra, or IBM, or AT&T itself. They have an offshore division, um, or Oracle. So these are some of the very big giants who always look for system admins. And then uh, not only, I mean, earlier in our early days, like when we were still studying, the system admin role was pretty different. Nowadays, as I explained, right, I mean, we are reducing the dependency on the physical servers, because you don't want to do that. I mean, no company wants to spend money on the data centers. So nowadays, what they're doing is they are using the cloud features which are provided by companies like Microsoft or Amazon or Google. So they are using, I mean, if I have my company, I would go for that because I don't have to set up a data center. Like, I don't have to buy servers and then, put it in the data center and then run my application or run my, code there, right? So I will do it. I will rather, give money to Microsoft and then buy their services, and they will manage all the physical and hardware stuff from their side. So excuse me. So here, these are some of the companies who are always looking for the system admins. And I mean, salaries, it depends. I mean, it depends on like where, if you're joining a service based company, the salaries are limited. Like you will be I'm not sure, but you'll be for a fresher you'll be paid a good amount of money, but uh, not as much as what product company is going to give you. Like product based companies like Oracle, IBM, Cisco, um, so these are some of the product based companies where like Amazon or Microsoft, so they're going to pay you a little higher side of it. So if you are good in the OS operating system, and then you are good in scripting, and then you are good in you are pretty used to all the commands. uh, on top of that, you will have to learn some of the technologies if you want to get into Amazon, or Microsoft, or any of those big companies. You'll have to learn some of the technologies where uh, you have to learn nowadays. I mean, I'm going to give you a very important part. You should know DevOps, because now every company is looking for DevOps engineers. So I mean, obviously it's a very big topic itself, but DevOps means like you should know uh, the the development part of it, and then you will have to manage it as well. So there are many nowadays. It's a trend. I mean, each and every company is following it. You will have to uh, you will have to know the DevOps and its tools, and the various technologies which are used in DevOps. So if you know this, you will be the top. You will be at the top priority to be hired, and then you will be paid a very good amount of money. Um, I have seen in my, like uh, when I was in US, I have seen like, there were many jobs which came to me, and they were paying like, 100K or 120K. You will get paid a very hefty amount of money. I mean, if you are really looking for a DevOps engineer job. But yeah, that for that, um, you not only know, you're not only strong in your basics, but also you should learn technologies like Kubernetes is one of the technologies which you should know. And then if you know this, if you learn this, if you do a CKA, that is a certified Kubernetes administrator. I mean, I still haven't done it. I'm going to do it. I still have that lined up. But yeah, if you do that, no company can deny your job application. So if you really do it, it will be very helpful to you. And yeah, I mean, that's pretty much of it. Uh, any other questions?
Uh, Thank you, Ijaz.
Hello, good morning, everyone. Hello, Izaz.
Hello.
My name is Tej Hiremat.
Hi, Tej.
Hello. I'm working on cloud data migration and application migration, completely related to simulations,
Mm-hmm.
not emulations or real-time work. It's my PhD topic. I work as an assistant professor with Sandeep.
Okay.
I just wanted to know, containers are being managed by Kubernetes, right?
Yeah, I mean, you can basically orchestrate all the containers. Yes.
Consider. I was working on my first challenge was application migration, which included data and its artifacts. So we stored the application as well as data in a virtual machine or a container, which is a more specialized version.
Right.
Are there any? I just wanted to know how you practically do it. Are there any tools for that for the migrations, or they do it using physical things just by the transfer of images, container images or virtual machine images?
Right. Right. So you can use something called as Docker.
Docker.
You can use it, and then you can build the image.
Okay.
Okay. There's something called
Okay.
as I have this command. So you can build your image of your whole application, and then you
Okay.
can push that image to Docker Central, and from
Mm.
there you can write a YAML file. um, I wish I have that YAML file. Let me quickly show you here. So this is my Python application, and this is my Docker file. So you
Okay.
can have something called as Docker file where, just a second, I'll show you this. And here you have this is actually for Python. I was working on Python, so I wanted to put Python on the Kubernetes. And this is the service where you can give reference to your application. So this is your image, and
Okay.
then if you create this service, and your application will be you can basically pull your application to the Kubernetes cluster where you're running this YAML file, and then your application will be hosted on that cluster, and then you can access it through an IPN port. So that's how simple it is. So instead of using a server and paying money for all that, you can put it on a Kubernetes cluster.
So if I want to transfer an application which is
Uh-huh.
present in a container from one cloud to another cloud, suppose if a Facebook, for example, WhatsApp doesn't have its own cloud storage, so it
Okay.
is using the Amazon services. Suppose if they want to shift it to Google,
Mm-hmm.
the entire application as well as its data.
Right. Well,
Can we go on a simulation for this?
yeah, I mean, you can definitely do it, but obviously that requires a lot of effort, because the reason is both of them they use like if they are hosted on Kubernetes, then no problem, you can do it very easily.
Okay.
But obviously you will have to work on spinning the virtual machine, and because AWS works a little differently, and then Google works differently, and Azure works
Yes.
very
Yes.
differently. So you will have to create the virtual machine there, and then you will have to take care of all the network and all the configuration, and then you can host your application. But it's possible. I myself have worked on migrating the applications to Microsoft Azure. So it's very challenging at the beginning, but once you start it, I mean, you can definitely achieve it. But the only thing is, if they're using Kubernetes, if they're hosting on like Kubernetes cluster, then there shouldn't be a problem. It depends, like where your application is hosted on AWS,
AWS.
whether it is using Kubernetes cluster or Docker Swarm, and whatever it is using. So, or
These are the
it's
two basic, right? Kubernetes and Docker are the main strategies which they use, technologies which they use.
yes. I mean, without that, your DevOps is incomplete.
Okay. Have you worked ever on container interoperability or virtual machine interoperability or application interoperability?
Um,
A
uh,
same application which works
uh,
on multiple clouds, heterogeneous clouds at a time,
mhm.
without any modifications required, without any changes needed.
No, I mean, that's something which I haven't dealt with. I know I have worked on migrating the applications from physical to containers,
Yes,
and
yes.
then migrating from physical to cloud. But there's something, I mean, in industries like we haven't. I mean, in myself, I haven't done that. But yeah, that's something pretty interesting, where you have a heterogeneous application
Environment.
of environment. Then you can just run it on any of the clouds. I think there is something called there's something like that, uh, but that's something I will be exploring too.
Okay.
Okay.
Since I'm working this from since 2 years, I did not find a solution for interoperability. We have worked on migration. Uh, if we have any queries in the future, can we mail you?
Yeah, I'll give my email ID. I'll put it here. You
Okay.
can definitely email me. uh,
Okay.
okay, I think we have to end this session.
Okay.
So
Thank you very much. Thank you.
Hello, is there any other queries from other participants? Or shall I conclude the session? HOD sir, shall I wind up the session?
Yeah, madam, you can wind up.
Okay, fine. Okay, sir. Okay. Good afternoon, everyone. It was a wonderful session. I would like to thank today's speaker, Shri Ijajahmed Momin, for sparing his precious time and sharing valuable information to the participants. Thank you, sir.
thanks for having me.
And also, I take this opportunity to thank management, respected Principal Dr. S.B. Kerur, Professor Basavaraj Kumbar, HOD, Department of Computer Science and Engineering, Mr. Sandeep Koppa, Event Coordinator, heads of all the departments, teaching, non-teaching staffs, students, and all participants for joining this webinar and for making best utilization of it. Thank you, one and all.
Thank you.
Thanks, Ijaz. Thanks, everyone.
Okay.
Hello, Ijaz.
Yeah, Sandeep, I'm gonna end it.
You can give the host rights to me. BGMIT is there, no? That one.
Okay, I gave it to you, and then BGMIT.
Okay, then. Yeah, fine. I will call you back later.
Okay, thank you, Sandeep.
Okay, thanks for your session.